Okay, going to start chapter 8. I'm going to switch my camera over and we're going to talk about two topics today. The first is searching, and the second part of this is going to be sorting. And your next problem, your next graded assignment is going to deal writing a program with different sortings in, and hopefully you opened it and looked at it at least. But we're going to talk about most of them today, and you're going to need to get those into your program. So here we go. Searching, first part of chapter 8. Searching. I have to start with Euclidean. There's something called the Euclidean method. Don't know that I need to do that. We'll find out whether or not later. First type of search is your most common sense search. It's called a linear search. Okay. You'll hear the term sequential. When it comes to this search, basically, we start at the beginning and we go to the end. I have a list, a homogeneous list of numbers. They are all integers. If I said, is the number 65 in there? Your eyes just jumped to the left and you went across and saw 64 and you said, nope, it's not in there. Worst case scenario is you went all the way through looking for this. This is a linear search. We are learning 5 different searches in CPS 162 right now. Just bizarre ways that in computer science you can do things other than well, if I'm looking for a number, I start at the left and I go to the right to find the number. Well, let's see. If I said to you, I have an array of size 12, it's called array num. Yeah, my worst case scenario is that it's not found. Let's write some pseudocode. What would the pseudocode be? So again, I'm doing test data because I drew an array and I'm thinking, what if I'm looking for 28 and that's not found? That's one case. It's not found. The other case, maybe I'm looking for 6 and it's found. Because once I find 6, what do I want to do? Oh, I want to get out. This isn't bad. I only have 12 items. What if I had 16,481 items? I definitely would like to get out as quick as possible. But right now, there's only two ways to succeed, and that's to get out of there. All right. So that means I'm going to get out of here 2 ways. And in my world, the 2 ways means I need to put this in a while loop. And I need to either I got all the way through and done or actually found it. Found's good. What would I make found? Give me a data type. Give me something that I could use for found.
A Boolean.
Yeah. I'm thinking I'm going to use a boolean for found. And when I get ready and go in here, I'm going to set found as false. It's going to be one of my ways to get out of there. I'm going to start. I'm going to go da 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 da. I need a number to look for. So I'm going to say input number. I'm probably going to need some kind of loop control variable. Da-da. Give me a loop control. I like counter. You know how I am. Int, int. Oh, wait a minute. What's the number inside of here called? Inside of the subscript,
The index?
the index. Let's do index, and let's give index an initial value. My pseudocode's going to look a lot like real code, except there's all kind of fluff all around this. So I have 2 cases. I find it or don't. And I have Boolean found in index. I get the number, and the found I set is false. What goes in the while? What's going to make me keep looking?
While found is false.
While found is false. Okay. Um, while found equals false,
And your index is less than your size.
and index is less than size. Okay. Before I move on, I need to do some thinking. Index is 0. I want it to be less than, so I want it to go all the way to 11. So yeah, I want less than size. Good. In a creative world, give me something else that I could put instead of found equals false.
Found equals exclamation point true. Is that what
Shorter.
you're thinking of, or
Give me something shorter.
You
0.
can use a break statement, can't you?
How about not found?
Well, well,
right? Yep.
Yeah. You're going to see this, especially those of you that stay with me for computer or stay with the program. Again, I don't know where they're going to need me or not. But this is really common, this not found instead of founding. Logically, I don't need to be super clever. I may have done while found is false inside of here. Okay. And then I'm going to have my loop. And one of the first things I'm going to do in my loop is I have initial value, I have a check. I'm going to throw this in here somewhere so I don't forget it. Get stuck in that loop forever. All right. What's going to be in the body?
Organs.
Organs. Yes. Yes.
Preferably.
What is the largest organ in the human body?
The brain.
The
Nope.
skin.
The
The
skin.
skin,
The
Well,
skin.
in on part of.
The
same thing.
skin is the largest organ. F. What do I got here?
If your index value is equal to the array,
Got that. Here's the number I'm looking to see if it's found or not. If that's true, I come in here and I'm looking for it. Okay. Then I'm going to do I don't know what from here. But I do know one of the things I'm going to have to do is found becomes true because that's my early way to get out of the loop. My index going all the way through this is going to be my other. And then I may have something like return found. If it's true, it returns true. If it went all the way through exhausted, it returned false. So it was nice having that flag of true or false. Remember, we called that a flag. Okay. Sequential. Start at the beginning and go to the end. I scribbled stuff down on paper. I handed that to you, and bam, you could be typing that up and done in no time. But we're not doing that. The next one is something called a binary search. There's a caveat. The list must be sorted. So in 10 minutes, when we start learning about sorting, we would sort the list first because it's going to be easier to search this. It's going to be easier to search this. In fact, it's going to be, instead of worst case scenario of the whole list, it's going to be a worst case scenario of can I find that number in blank moves? And that blank move is going to be based on base 2. So 2 to the 6th or 2 to the 4th power is 16. I should be able to find this in 4 moves. Now, sounds a little similar to those of you who had me in 121. Pick a number between 1,000 and 24. Inclusive. Inclusive. we had a program. Guess a number between, guess 1 to 1,024. And what happened after the guess? What did the program do? For those of you that had me, told you your guess was too high or your guess was too low. And then you guessed again. Yeah. So when I got ready to run your programs, I changed that to 10 so it didn't take so long. But when it's 1,024, how many guesses should it take you to get this right? Well, what should your first guess be?
About
Right in the middle.
512.
512. Yeah. And then based on higher or lower, you just keep cutting that difference in half. And you should be able to get this in 1,024 kilobytes, 2 to the 10th power. 1,024 is 2 to the 10th power. It's a kilobyte. So if you had 1,024 numbers in this array and you picked the middle one and it said higher, you should be able to find it in 10 guesses instead of 1,024 guesses. So does it make sense to sort it, then guess this way, or go through 1,024 times? There's ways to calculate that. Let's see again. I had some numbers like, let's see, what if it was, some test data again, 28. What if it was test data 42? I'm going to make sure it works. So 28 doesn't exist. 42 does exist. So now I'm thinking, I have to do, boy, what would you do? Just give me some notes. Give me some notes. How would we go about search or taking care of this?
You'd find the midpoint first.
Find the midpoint. Okay. So what would I use to find the midpoint?
The size.
The size. And what would I do to the size?
It would be size divided by 2 and then minus 1
Okay.
for your
Let's,
index.
I'm thinking size divided by 2 because let's see. My first guess, would be something like yeah, I need to go through this. I have the subscripts from 0 to 11, and my first guess might be something like just a rough number in the middle. It'd be like 6. Now, we're going to look at higher or lower. If it's lower, now instead of having 0 and 11 as my end numbers, I'd have 0 and 6 as my end numbers. If it was higher, I'd have 6 and 11 as my numbers. So somehow I need to get in the middle of these and go through, get in the middle of these. And a moment ago, somebody said, say, take size, which was 12. Okay. What's your, next guess here might be 3. And then I'm looking at 0 to 3, 4 to 6. I don't want to overlap 6. So as I'm going through getting ready to do this, where I'm dividing by 2 and where I'm using a first and a last. Now this becomes the first, this becomes the, boy, it'd be nice to be able to keep pulling a function where I'm passing in the first and the last, but I don't want to double up on numbers and things like that. And I want to exhaust it down to how would I tell if it's found? How would I tell if it's not found? Again, this number in here is 9, so maybe 7 to 9 and 10. So you'd have to double your numbers to make sure this first and this last subscript. Again, this is a little harder than 121 because I got to figure the math out a lot of times first. Yeah. Yeah. So I need to make sure I have a nice way to use my first, my last, find something in the middle that's an integer, and then higher or lower, and what am I passing? 0 to 6, 7 to 11, 0 to 5. I mean, how am I going to do all that? So we're not going to write this when it's in the book. And I think 8-1 was the linear in the book, and I think 8-2 had the other one in. Yeah. So
8-2 is binary, yeah.
yeah, so we don't need to go through this. The sorting's going to become more important. Concept is what I wanted you to get out of this. Okay, so now we have a list of numbers. And we're going to take a look at section 8.3, and we're going to learn a couple of ways to sort. First thing we need to clarify, I have ascending and I have descending. Low to high, low to high, high to low. 0 to 100, Z to A, whatever we're talking about. We have low to high, Z to A, high to low. With sorting, we're going to talk about some basic concepts. The first basic concept is this one. And there's a lot of different sorts that'll blow your mind in 162 when we talk about them that use this concept of an exchange sort. All right. Let's take the test data and see what we got. Okay, an exchange sort uses a swap. True or false? If I make a swap, I'm going to mark it as true. If I don't make a swap, it stays at false. So it's going to use a swap. It's going to do these side-by-side comparisons. 0 to 1, 1 to 2, 2 to 3, and all the way out. It's going to use a swap function. We saw a swap function somewhere, didn't we? Yeah, we used two reference variables. We went in and we were able to swap the two. Yes or no?
In past assignments or something that we did currently?
Somewhere along the line, we how do I swap two numbers? Paper. Number one.
It was in the code listing. That's why I'm
You
thinking
had
of it.
you had a swap. Okay.
Yeah.
Could you make that a function? Could you use reference variables to pass them in and swap them? You would have to, because you want them both to change. Okay. This repeats until no swaps are made. That's done using a do loop, but we're also going to use a for loop. This type of sort is bad for large arrays. All right. Let's see what we got. We're going to compare 0 to 1. Do they need swap? I'm sorting this in ascending order, low to high. Do they need swapped? Again, this is 0, subscript 0, subscript 1. I'm going to check 1 and 2. Do they need swapped? Yes. Guess what? Since there was a swap, my swap was made true. So swap started out as false. There's a swap. So that means I'm going to do it again. 14 and 9. There's a swap. 14 and 20. Nope. 20 and 38. Nope. 38 and 40. Nope. 42 and 24. Yep. 40 and 33. Yep. 40 and 41. Nope. 41 and 27. Yep. 41 and 30. Yep. After all that, what was accomplished?
A
It's
slightly more sorted array.
The largest number is in the correct position in the array in the last slot.
The largest number trickled down all the way to the end. Now, we got to do it again because swap became true. let's see, if I'm gonna write some code, I'm gonna start swap out as false. And I'm gonna do this. Look like this is gonna be my for loop. How did I go through with the for loop? I checked 0 and 1, right? But what's my for loop look like? Where do I want to start?
The first position, which would be 0.
0 and I'm gonna go until something, and I'm gonna go plus plus. And I'm not sure of that just yet. Oh, look at that. Good, don't look at that. Let's see. Give me an if statement.
Array at position counter is brain's not working. Less than or greater than array at counter plus 1.
It's
Greater than.
greater than array, the next one, counter plus 1. Then I swap them. You have the code for that. In your program, don't type swap them. This is pseudocode. So if I do that, what else do I need to do?
Set swap to true.
Yeah. So inside of here, I'm going to need swap equals true. Okay. So this is my for loop. This is the body. Since it's pseudocode, I can do whatever I want. And so if I come in, I'm checking 0 and 1, 1 and 2. My array size is 12, correct? What should this be? What numbers do I want counter to have? From 0 all the way up to,
11.
well, if I say 11 here, what's this one going to be?
I see. So
12.
10.
So
Yeah.
10. So I want counter to be less than 11? Less than size minus 1 kind of deal? Yeah, that's why I waited for a minute. No, I don't want it to be, yeah, I want it less than 11. So this is 10, and this will check with the 11th subscript. Okay,
But I imagine size minus 1 is great if you're not certain of the size.
right. So I come in and I have the ever popular do. I might want to make swap. I don't need to do anything because I come in and make it false. Swap is false. I come through. This is going to be while. I want to keep doing this while swap equals false. Or again, not swap.
Shouldn't it be true?
I want to
Only once it leaves the for loop.
Yeah,
Ah,
if it comes out of
within a
here,
loop.
it's true. That means there was. Oh, I apologize. You are correct.
Yeah. Oh, good. Thank you.
Yeah. While swap happened, we come back up and do it again. Nice. Nice. I'm starting to think I might be getting you trained into doing typing's easy. It's the thinking part that's hard, and don't mix the two up. So this again, we had a bunch of notes, compare side by side. Give us more. I know, right? Give us more. Look at that. I have more. The Dan sort. Okay, this last one was called a bubble sort. Somewhere along the line, I learned this as the bubble sort. Why? The last one, the largest number bubbled to the end. The bubble sort. This is also called a bubble sort, but since it's not in our book, I'm giving it to you, and it's called the Dan sort. This one's kind of interesting as well. If I get ahead of you, let me know. If you're copying down, you want me to stop talking. And again, the size is 12. Oh boy, we want to go through and swap them. All right. So here's how this one's going to work. I'm going to start at 0 and compare it to 1. If they need swapped, I swap them. Then I'm going to compare 0 to 2, 0 to 3, 0 to 4, dot, 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 0 to 11. This guy's actually working in reverse. He's going to put the smallest in the front. The smallest will bubble to the front. Once I'm done that, I'm going to go through and loop again. This time I'm going to use the subscripts. Anybody have a guess?
You mean the starting subscript?
Well, 0 is already in the correct place and done. So now I'm going to go 1 compared to 2, 1 to 3, 1 to 4, 1 to 5, dot, 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 1 to 11. So that the second smallest bubbles up here to subscript 1. I guess I know what's next. Start at 2, 2 to 3, 2 to 4, dot, 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 2 to 11. All the way down to what? Subscript
All the way down to 10 and 11.
10. Yes, I'm going to do 10 to 11. So I could do this guy in 2 for loops. For loop. 4. Counter 1 equals 4. Counter 2 equals. And then I said something along the lines, if array sub counter 1, I'm going to compare it to array sub counter 2 somehow and swap them. Swap them. Oh, 2 loops again. This time I have 2 4s. Last time I had a do and a 4. When am I going to swap these? When the second one is smaller. So if this is greater than that, I swap them. If the earlier one is greater, then I swap them. If the earlier one is greater, so I took care. I had to do this nice and slow. I needed all of this. Let's see, for counter 1, where's counter 1 start at?
11.
Zero.
Well, it starts at 0.
Oh, because the first, right, my bad.
And how far does counter 1 go?
So it's less than size.
Yeah, da, 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 da,
Or less than 11.
which is size,
-1.
yeah, less than size minus 1. Increment, counter 1. Counter 2. Where does that start at?
1.
Okay, where does it start at?
Uh,
Counter 1 plus 1.
There you go. Counter 2 starts at counter 1 plus 1. It went all the way up to 11. So this time, less than size. Counter 2 is less than size. Counter plus plus. Counter 2 plus plus. Ah, ran out of room. Note to self. When I teach this again in another 5, I haven't taught this in 5. Well, a little bit last year, last semester. I haven't taught this in 5 years. Been a while. So now you see why I kind of like the dance sort. Once I got this, I knew it's a for loop and a for loop and done. I didn't have the do and the for and the flag and the different way to solve the same problem. Okay, this was another exchange sort because I exchanged them and I may have exchanged a lot of stuff. The last one, I may have exchanged a lot of stuff. This one's brute force. It's going this many times no matter what. 11 plus 10 plus 9 plus 8 all the way down to 1. This if statement gets executed that many times. This one's a little nicer because if it's sorted right away, I can get out. So there might be times where this one's a little better, efficiency wise. Okay, exchange. We're now going to look at something that's called a selection sort. A selection sort. And as you can see, a selection sort is going to select an item and move it to its final spot. It's going to select a particular item and move it right to it. I like to move it. It's going to move it right to its final spot. Oh boy. All right. Well, let's see what's going on. I want to say I'm going to start at 0. I'm going to go through and find where the smallest one is. It might be here. And wherever that is, I'm moving it there. I'm thinking I need to go through 0 and all the way up to the end, right? Size is 12 again. I need to go 0 and check with all of them. I need to go 1 and check with, and 2, all. Okay, so let's see. I'm going to start out with a loop. And what am I going to do? Right now, I'm starting and I'm going to say, hey, my smallest location right now is 0. My small value is 4. I'm going to run through the rest of these. I may be changing small location and small value. And when I get to the end, I'm going to switch them, swap them. Oh boy, here we go. I'm going to start with this outer for loop. A lot of times I start in the middle and work my way out. For your next program, you have to do a shell sort. I give you a flow chart. You will start in the middle and work your way out. If you go on the internet and you find a solution that has 3 for loops and you try to give me that, I'm kicking you out of the class because I will know you stole the solution off the internet. I want you to do the shell sort my way, and you will see you need a do loop, you're going to use a while loop, and you're going to use a for loop. That's what will match the shell sort that I give you. Okay, so we're going to come in, and I think I'm going to have for counter 1 equals 0. Counter 1 is, how far out do I want to go? To 10 or to 11 or what?
You have to go all the way to 11, right?
Okay. But if I get to 11, what do I have to compare it to? Remember, I'm taking 0 and I'm going to compare it to all of these. Then I'm going to go to 33, compare it to these 3. I go to 41, compare it to those 2. I go to 27, compare it to that. And I think by default that would be done. So I'm going to go with counter 1 is less than size minus 1 again. I'm going to, keep that in mind when we get there. Okay. So my small number right now, I said to start, my small number is going to be 4. So my small number is going to equal array sub counter 1. And my small location is going to equal counter 1. All right. Now I need to go through the rest. So I'm going to have a second loop. 4. Counter 2. Where does counter 2 start?
Gonna
Where I
start
got,
at counter 1+1, right?
there it is again. Yeah. It's going to go counter 1 plus 1 again. How far out is this guy going to go? All the way less than size. Counter 2 plus plus. Oh, okay, and this is all the body here. All right. So now I'm going to come in and I have an if statement. If something happens, I'm going to get a new small and a new yada yada.
If the array at index counter 1 is less than the array at index counter 2.
Array sub counter 1. We're going to compare it to array sub counter 2. And something good happens when array sub counter 1 is what? If it's less than, it's good. Nothing happens. If it's greater than, something's got to happen. What's going to happen?
They
They'll
swap.
swap.
We're not swapping them. We're only storing until the end.
You're gonna
What are we
change the
storing?
small location.
Yeah, small is going to get a new value. So maybe up here, I should change this guy.
Oh, so it's going to be the array with like the small location.
Or so what if I say array sub counter 2? Okay, array sub counter 2, that's all these values. If that's greater than, I call this small value. Yeah, if this number is smaller, is greater than small value, I didn't put value up here. Greater than small value gets the value of
The array
here,
counter 2.
array sub counter 2. It's the value that's there. And small location is going to get the value of. So I'm coming through. I have a small value of 4. And I'm coming through checking. And if one of these is,
Wouldn't it be less than, not greater than in that
yep,
case?
Yeah.
that's why I keep looking back to the array.
Mm-hmm.
I know what it is. I have the answers here. I already did it by hand, so I'm looking over. If it's less than, oh, I have a new small val. That's good. And I know it's located. I want to know where it's located.
At counter 2.
At
And it's only going
counter
to change anytime that
2.
if statement is true.
Yep.
Yeah.
So I do that. And now I come back up and I'm going to keep going through this for loop. When I come out of this for loop, I'm going to do that swap. So let's say this was number 3, and this is out at location 10, 9, 8. This is out at location 8, and this is a number 3. That means small value somewhere along the line got the value of 8. Did it not? Small value got the value of, excuse me, small value got the value of 3. This guy became a 3.
And the location would be
Yep,
the
from
8.
that
Yeah.
location. So it got the value of 3. It's located at location 8. It's got the small value of 3. It's located at location 8. I went through and found good. Found where the smallest one is. So now I need to swap. What am I swapping?
You're swapping the array index of control 2 with the array index of control 1.
We're swapping. Let me redo this. We are swapping. I need to get the 3 over here and the 4 over there.
So you're swapping the first control with the new like small location, right?
Array something with array something. We're swapping an array subcounter 1 because that's where this is at. That's where this is always going to be. We're going to swap counter 1 with array sub
Small
Small
location.
location.
all location. Good. Small location. Capiche? Concepts. We had to go through the concepts. How's all this going to work? I led you a little heavy to come through this. What I'm also really trying to get is you got to do a lot of this sometimes before you can start typing. I needed this. I need example. I need test data. I need to, yeah, I need different colors because this was the number 3. This goes to small value. The location goes to small location. So I needed my original one to be swapped with that small location. What's it say at the bottom? Put all of the sorts in a single program. You got 3 of them. I would recommend you make them functions. I'm going to put you in groups. After you put the 3 of these in functions, and get them to work, create an array, fill it with random numbers, try a sort. Block this one out, try another sort. You don't have to have all 3 of them working at the same time. Document, get this working, great, document it out. Get another one, put all 3 of them in there. Then I want you to share it with your group. I don't want it shared on content. And the reason is when you look at what the next program is, you benefit from your group work today to build the next program. Okay? Everybody understand what I want you to do? Let's see how many people. Awesome sauce. We have 15 people. That's 3 in a group. Don't anyone just up and leave as soon as I put you in groups. Please. My 121 class, 5 people left when I put them in groups. I'm like, what the? This will definitely benefit you. The 3 of you working together, email it to each other, however you want to do it. But this will get you started for your next program. Any questions? See, I need to make sure so-and-so is not with so-and-so. And we need to break up certain groups. And
Hey, you don't need to do that, by the way.
okay. Again, it's always all random. It's getting to know people in the class. All right.
Sounds like you're making it not random when you say what you did.
I say that randomly.
You know,
Here we go.